All right, this is the last problem on the second homework for Thermodynamics 2 at School Minds. This is Clausius-Clapeyron homework with Gibbs free energy and equilibrium, but this is a Clausius-Clapeyron problem, so because it says, I want to use Clapeyron equation. So now normally you have to be like, normally the first step is to identify this as a Clapeyron problem. But when it says, I want to use the Clapeyron problem, well, that step's already done for you. So h alpha, dp dt equals h alpha minus h beta over t b alpha minus v beta. Alright. So I want to use Clapeyron equation for a substance similar to argon. So what substances are similar to argon? That's right. Ideal gases. It's just my hint. This is an ideal gas. Okay. Comparing boiling temperatures. Okay, so I got 400K at 5 bar and I got 300K at 1 bar. Okay. So I have basically a T boil. I have like a T1, add a P1 and a T2, add a P2. Okay. I'm using the equation to find constants in delta H of vaporization. So I have delta H of vaporization is equal to A minus B over T squared. Okay. At 300K, delta H of vaporization is equal to 60. So, when T is equal to 300, okay, this is equal to, so delta H vape at 300 is equal to 60. All right. Use this in the Clapeyron equation to find A and B. So I have two unknowns. I need two equations. Well, there's one, and there's the other. Additional note, do not plug in any values into the last step and keep everything as variables until the last step. I shouldn't have to make that note, but hey, I was being nice. Okay. So I recognize this as a Clapeyron problem. What's the second thing? I write down my assumptions. Now, again, you don't have to go through all four assumptions every single time, okay? I have up to this point on this homework, but I'm not always going to do that. I'm not going to do that here, okay? Well, okay, maybe I will. But I'm not going to write them all down. Okay, so what's the first, what's the first assumption? Or what's a first assumption? Well, I already mentioned it. It's an ideal gas. Let's write them over here. So ideal gas. Yeah! I already said it's an ideal gas, essentially. Okay, so that's a good assumption. And, I'm looking at the temperatures, I'm looking at the pressures. 5 bar is still ideal gas range, it's still kosher, and it says it behaves like argon, so let's just assume that that's kosher. Okay. Delta H vaporization is constant. So delta H vaporization is constant with delta T and delta P. Now, is that one kosher? Well, is my temperature range small? Yeah, it looks pretty, 100 bar. I mean, we've done 100K before. What about my pressure range? Yeah, that's pretty small. I have 4 bar. But I have an equation, so I can't assume it's constant, okay? So that's a bad assumption. I mean, I've already stated that it is not constant, so it's not an assumption, it's a fact that it is not constant. I'm not assuming it's not constant, it's a fact, okay? So that's a bad assumption, okay? The one that's similar to that, delta V is constant with delta T and delta P. Well, like I said, the delta T and delta P are small, so is delta V constant? No. Why? It's a vapor. Delta V is never going to be constant when I'm a vapor. I mean, ideal gas says RT over P is equal to V. If I change T, will V change? Yeah. Same thing with P. All right. And then the last assumption we like to make is that V alpha is much, much bigger than V beta. Is that true? Yeah, it actually is true. Why is it true? Well, because one is a vapor, one's not. So, and unless you're out in outer space, there is no vapor-vapor equilibrium. Okay, so if I have a vapor and I'm on Earth, I can always assume that V alpha will be much, much greater than V beta. And that's actually that's a good assumption. The other one's in it. That's a good assumption. Okay. But those are only two assumptions that we have in this situation. Okay. So now that we've made our assumptions, well, we separate and put them in the integral symbols and start applying some math. And applying the assumptions. So we have, dp from P1 to P2 is equal to T1 to T2. We've got delta H. We've got T V alpha minus V beta. dt. Okay, well, we've already said that that's going to be equal to 0 because of assumption number 2. Well, that's not being pulled out of the integral because that's not being assumed. But we can assume that this is RT over P because of assumption number 1. And, well, it's not an assumption, it's just a fact that this is equal to A over minus B over T squared. So we're just going to plug that in. Okay. So let's apply all that math and rearrange things a little bit. It's a little trickier, but, well, we can at least rearrange that P. So that P2 over P1. And again, when we're rearranging, we always want the P's on this side and we want the T's on this side. Okay? So we see this P, we can move that one over. Let's see if we need to do anything else though. Okay? So that's A minus B over T squared all over RT squared. Because I got this T and this T, so that's T squared, and then I have a dt. Well, you know how much I love fractions within fractions. Okay, so we need to clean that up. But let's just really quick, is there any P's? No, so this part's good. So we could just do this part and say it's natural log of P2 over P1, and I'm good to go. Okay. But let's distribute this first. So let's multiply T squared over T squared. Okay. So this becomes from T1 to T2. T2. So I have A T squared minus B all over RT to the 4th. Okay. dt. I don't know how to do that math off the top of my head. Okay. And I actually don't even know how to do that math. I mean, okay, yes, I can do separation and integrate, separate and integrate, okay. I hate doing separation and integration. I am not going to expect you to do separation and integration, okay. I'm not going to expect you to do U substitution, because we could do some, maybe some U substitution. No. How would I move forward this? I'm going to look up in my calculus book how to solve that, and then solve it, okay. I don't have a calculus book on me, lack of foresight here. And so, and on a quiz or on a test, I would say, what I would have is like, x squared over, x squared minus a over x to the 4th, because that's essentially what I have, because everything else is a constant, and then how to integrate that, okay. Wait, no, I'm crazy. You can integrate this, can't you? Let's see here. T1, T2, yeah, let's see here. So A over RT squared minus, ignore what I just said. I can integrate that. But that's what I'm saying. But in general, though, sometimes I can't, okay? And so I'll need, but that I can integrate. Okay. So let's do that. I've already applied my assumptions, so I can resolve that stuff. Let's keep my delta H vape, so I know what that is. All right. So I've got natural log of P2 over P1. Okay, we got A over RT squared. So that becomes minus A over RT. Yep. And then plus, because of that minus, A over RT3, I need a 3 there because of the other 3. So A over 3 RT cubed, okay, from T1 to T2, okay. That's B. Okay. Well, let's see here. Is that good to go? Yeah, so this becomes natural log of P2 over P1 equals minus A over R from 1 over T2 minus 1 over T1. We've got plus B over 3R, 1 over T2 cubed minus 1 over T2 T1 cubed. Okay, and we have T1, we have T2. What don't we have? We don't have A and we don't have B. But I know everything else and I have two equations, two unknowns. I just needed to use algebra at this point. Okay, and so, I solve for like this one. Let's just, kind of do that in a sense and say that 60 plus B over T squared, which is 300. So B over 3, and you know how much I love plugging in numbers, and so I won't really do this. Let's just do delta H vape at condition 1 plus B over T1 squared is equal to 8. That way I can keep it in variables. Okay, and then I plug that A in over here, solve for my B, and then plug that back in to solve for A. Okay? But at this point, it's just algebra.